Swayam Prabha. Digital India. Educated India.
Good morning, good afternoon, good evening my dear friends and participants for this course. I am Raghunandan Sengupta from the IME department IIT Kanpur, and you are all taking this TKM2 course under the NPTEL MOOC lecture series, and this is the 24th lecture. And if you remember that at the last end fag end of the 23rd lecture, I was discussing that for the fractional factors, how you can reduce the overall number of significance of calculations, and then based on that you proceed. So, we consider A separately where effects of B and C are negative, and then we consider B separately where the effects of A and C are negative, then we want to combinations of A, B and then and so on and so forth. And I also mentioned that how you can analyze these problems on a very simple diagram of the size of either a square or a cube, only for the level of 3 dimension, because for higher dimension it will be difficult for us to understand. So, let us continue the discussions further. So, when we estimate ABC, we are really estimating the combinations like this. We want to find out A plus the combinations effects of B and C. When we are trying to find out the B, it is B effect plus AC, and when it is only C, it is C effect plus AB. So, 2 or more effects that have this property are called the aliases, and based on the aliases we can find out the level of significance which is there. In our example, A, B, C are combined together aliases, B and AC are one set, and finally C and AB are another set. The notions of these combinations are given as A is related or found out by the combinations of A plus BC, B is found out the combination of B plus AC, and C is found out by the combinations of C plus AB. Now, suppose that we have chosen the other one half of the fraction, that is the treatment is combined in such a way that we have the table 8.1 associated with minus in the ABC column. So, in practice it does not matter which fraction is usually used. So, both the fractions belong to the same family. So, based on that we can do the calculations. This alternative or complementary one half fraction consisting of the runs of I or AB or AC and BC are shown, and this defines the combination so that you can find out the overall effect of the I or the identity values for the combination of ABC if there are 3 factors. The linear combination of the observations are given as A prime, B prime and C prime. So, A prime is basically combinations which gives you the effects of A and the effects not coming from B and C, because B and C does not have the effects of A as such. For B prime it will be B and without AC, and for C prime it will be C without AB. So, design resolution. The preceding 2 to the power 3 minus 1 design is called the resolution of the third degree or third design. In such a design, main effects are aliased with 2 factors interactions, and combinations can be done accordingly. For a higher factor, for 4 factors ABC, we can do it for a combination of 3 and lower levels. For a 5th factor, we can do it for combinations of 4, 3rd, 2, and but obviously what would be significant would depend on what is the level of effects we want to have. A design is of resolution R if no P factor effects is aliased with another effect containing less than R minus P factor. So, these are the levels of the values which you have. We usually employ a Roman numeral for the 3rd design, 4th design, 5th design, whatever it is, subscript to denote the design resolution. Thus, 1/2 fraction of 2 to the power 3 design would be defined in such a way, it will be basically 2 to the power 3 minus 1 on the superscript, and the subscript would be Roman 3 considering the resolution of 3 design which we have for our example. Next, we design the design of the resolution of the 4th design factor, 5th design factor and the 6th design factor. We can do it accordingly. Resolutions of the 3 designs. So, these are designs in which no effects are aliased with any other main effect, but main effects are aliased with 2 factor interaction and some 2 factor interactions which are there, which may be aliased with each other. So, the effect of t to the power 3 minus 1 design is given in table 8.1, which is of the resolution 3. So, hence you will have basically 2 to the power 3 minus 1 and subscript Roman 3. So, resolutions of 4 designs. So, they are design which no main effect is aliased with any other main effect or with any 2 factor interactions are not combined. So, what you are trying to do is that for a level of 3 where you have A, B, C, you will break down into small subsets and find out the effects combined together in such a way that the overall effect is basically mirrored, such that the combinations give you the best resolution of the effect on a 3 design factor. If you have 4 design factor, such that you basically want to go to a high level of significance. So, that can be done in 2 ways. Number 1, where you have the effects of A, B, C, D. So, based on the A, B, C, D, you can basically have the effects such that the combination of A, B, C, D taken 3 at a time would give you the first level of significance. Then A, B, C, D taken 2 at a time would give the second level of significance, and then you can basically find out the single effects and combine them for the single effect, the double effect and the triple effect in such a way that the overall significance comes out to the maximum possible extent. So, obviously, in that case the resolution or the subscript notation would be given as 2 to the power 4 minus 1 suffix 4. So, the 4 minus 1 would give you the number of combinations you are doing, and the design factor would be given by the subscript, which is basically the superscript would be given by 4 minus 1 as I mentioned, and the subscript would be given by the Roman number 4, such that it will mimic to what level of significance you want the experimenter to do the experiment or find out the resolution. For resolutions of 5 designs, so these are the design factors in which you will have 2 to the power subscript being with Roman 5, which because it is of the level of 5 degrees. 5 degrees is not the degrees of significance, it is basically the 5 design experiment which you are going to do, and the superscript would be 5 minus 1. So, it will give you that 2 to the power 4 are the total number of combinations based on which you can find out the effects to the maximum possible level. Construction and analysis of the 1/2 fraction. So, 1/2 fraction of the 2 to the power or 2 to the power k design of the highest resolution may be constructed by writing down a basic design consisting of the runs of those factors of 2 to the power k minus 1, which is the fractional fractions, and then adding the kth factor by identifying its plus and minus levels, and then adding the pluses and minus in such a way that you find out the overall effect and what is the level of significance. So, if you remember in the table or the chart, on the leftmost column you will have all the factors, and the topmost row you will have all the factors written separately. So, what you do is that you find out the combination of A's effects on A, on B, on C, on D if there are 4 factors. Then try to find out the effects of A on AB, effect of A on BC, effect of A on CD, and continue in such a way such that you will give the plus and minus sign to basically denote the level of significance. When you have the level of significance, this is not the numeric value, this is the plus and minus sign. Once you are sure about this level of significance, you add them up in your overall factorial design such that you get the effect to the maximum possible way which is possible. So, the 2/2 fraction of the 2 to the power 3 design problems are given like this. For runs, which is given on the leftmost column, which is 1, 2, 3, 4, and the full 2 to the power square factorial basic designs are given, which you have basically A, B combined together. We have basically 2 to the power 3 minus 1 suffix numeric 3, which is given in the second block, and 2 to the power 3 which is given in 2 to the power 3 minus 1 and by 3 which is given in the third block basically signifies the levels accordingly. You have the effects of A, which is basically if you go through the columns, which is minus plus minus plus. Then you have the effects of B, which is basically given by of a minus minus, which signifies the level of the runs for 1 and 2 is negative, for 3 and 4 it is positive. Similarly, when I go to the combinations of 2 to the power 3 minus 1 suffix numeric Roman 3 and 2 to the power 3 minus 1 suffix numeric Roman 3 with an effect where I the identity factor is ABC and in other case is negative, then you basically have all the plus and minus signs given accordingly. So, if I go back to the figure which is given here, it is exactly what I said a few minutes back. So, what you have, we are trying to basically combine ABCs in which direction the orthogonals will go is immaterial, so long they are 90 degrees to each other. So, consider that you are measuring in this diagram B along the vertical, which is top, and if you are considering C which is coming from your end to mine end, and if you are considering basically A, because you consider the camera or you are the origin, and if you are considering A which will be going from your side to the left hand side would be A. So, when I basically do a mirror image of the combination of, say for example, C and A, it will basically the combination of C and A would be done in such a way that you will find out the effect of B is not there. When I try to find out the effect of A and B, it will be on your side onto the wall, such the C is not there, and when and in that case the initial example when I am considering the effect of C and A, it will be the floor, because the B effect would not be there, and when I am trying to find out the effect of B and C, it will be the combination on the left wall without any effect of A. So, obviously, you can break them into 3 orthogonal planes and find out the combinations accordingly. So, projections of a factors in the factorial. So, any fractional factorial design of resolution R contains complete factorial designs. So, possibly to replicate that in a subset of R minus 1. So, it can be done in such a combination where you basically add and subtract the combinations accordingly to find out the level of significance. So, this is important and a very useful concept. For example, if an experimenter has several factors of potential interest, but believes that only R minus 1 of them are important effects, then a fractional factorial design of resolution R would be appropriate in order to basically bring the level of significance to that level which the experimenter wants. So, if the experimenter is correct, the fractional factorial design of resolution R will project into a full factorial in R minus 1 significant factors, because the maximum possible resolution of 1/2 fractions, which is to the 2 to the power k, can be designed in such a way that the combination can be taken together, which means that furthermore, as we take the design, it may be projected onto 2 replicates, 3 replicates or 4 replicates, depending on the level of significance on the efficiency front which the experimenter wants to do. So, let us consider an example. Considering the same filtration rate example, the original design which basically has is a single replicate of 2 to the power 4 design. In that example, we found out that the main effects A, C, D and the interaction of AC taken 2 at a time, which means you are trying to find out the effect of A and C. Then you are trying to find out the effect of A and D were different from 0 levels, hence they were significant. We will now return to this experiment and simulate that what would have happened if a 1/2 fractional design of 2 to the power 4 was run instead of the full factorial model. So, consider this example. A chemical product is produced in a pressure vessel. A factorial experiment is carried out in the pilot plant to study the factors, what are the effects which is coming on for the factors. The 4 factors are: A is temperature, B is pressure, C is the concentration of the formaldehyde, whatever chemical we are using, and D is the stirring rate as you mix these chemicals. Each factor is represented at 2 levels. So, basically you will have temperature at 2 levels, pressure at 2 levels, level of concentration for the formaldehyde at 2 levels, and the stirring speed would be at 2 levels. The design matrix and the response data obtained from a single replication of the 2 to the power 4 experiment are shown as given. So, the runs are given on the leftmost column. So, the runs are basically the combination based on which you are going to take. The factors which we will denote are A, B, C, D, corresponding to pressure, corresponding to concentration, and so on and so forth, as I read. So, if I consider the runs on number 1, so basically we are taking the run at level 1, which basically where there is no effect. Then and it is a static level. When I consider effect of run 2, it only gives me the level of significance. So, 2, which is the second row, corresponds to the fact that I am only taking the effect of A which is replicated by the run level which is given here. When I go to, say for example, go to 3, I will use the same color to denote that. When I use 3, so 3 would have an effect on basically a factor B, and factor B would be there coming out in the run level, because the label based on which the run is being run would basically be signified by the factor effect which is coming into the picture. When I take 4, it is an effect of, say for example, both combined together A and B. So, the minus signs obviously would mean there is no effect which is coming from there, and hence the run levels would be B, A, B combined. When I go, let me take a different color. It would have been best if I use different colors for different schemes, but because they become very dark, so it is difficult for us to make the significance level. So, for the fifth one, you have only effect of C, hence the run label is given as C suffix. If I go to the, I am going now down the rows. If I consider the run level number 11, it is an effect of factor B, it has an effect of factor D, hence the run label is given by a factor BD. If I go to the second last, which is the 15th one, I am just going arbitrarily. So, once you understand all these things, each and every plus and minus value in each and every row would now make sense to you as you go one at a time. So, if I go to the 15th run number, the effects are coming out from factor B, factor C, factor D, hence the run label is given by a suffix BCD or the names BCD, and finally, the last run, which is 16th run, has an effect of A, also of B, also of C, and also of D, hence the run label is given by A, B, C, D. And the filtration rate which you had, if you find out, for each such combinations are given on the last most column, and they would be utilized in order to basically find out the level of filtration plus the effect of all these 4 factors A, B, C, D, each at 2 different levels of significance. Significance means the level of the value. So, pressure can be, say for example, at 1 Pascal, and another case it can be 2 Pascals. Similarly, the formaldehyde concentration may be 100% or, say for example, 50%. So, based on that I have 2 level of factors, and all of them are being combined together. So, it will be 2 to the power 4, because there are 4 factors in this example. So, now we will use the design of 2 to the power 4 minus 1, because the choice of the generator would result in the design of the highest possible resolution, which would basically be the resolution of Roman numeric 4. To construct the design, we first write down the basic design, which has basically 2 to the power 4 minus 1, which is 2 to the power 3 design factors as shown in the first 3 columns. This basic design has the necessary number of runs, which has 8 in number, but only 3 column factors are there. To find out the 4th level, which is basically the level of significance which we have to find out A, B, C, D combined together, we need to basically resolve it. Thus, the level of D, which is the 4th factor in each run, is the product of the plus and minus signs which is given for A, B, C combined together and taken separately. So, combination can be 2 at a time or as well as 3 at a time. When I am doing a combination of 2 at a time, the combinations are AB, AC, and you will have basically BC, and when you are basically combine them and taking them 3 at a time, it will be the combination A, B, C taken all 3 at the same time. The process is illustrated in the table which we will just discuss, which is table 8.3. Because the generator for A, B, C, D is positives, hence we will have basically the design factor given as 2 to the power 4 minus 1, because there are 4 factors and we are basically decreasing the level of fx which is coming out for them. So, it will be 4 minus 1, and the subscript would be basically be 4 in the numeric one, which basically gives the highest amount of resolution which is coming on for the factors. So, if you have this, the combinations would be given as this. So, now remember that drawing the 3-dimensional cuboid for 4 dimensions, it would not be possible. So, what we will do is that we will first go in this level, and this may change depending on the type of experiment which you are doing. We will first draw the combination of 3 dimension for ABC and do it corresponding to the fact that the level of D's are at different levels. See, for example, if you remember, we mentioned very categorically before we started the experiment or the example that each factor is at 2 levels. So, obviously, D would be at a level of lower significance which will denote as D minus, and there would be a higher significance which would be D plus. So, obviously, there would be 2 cuboid for D, 1 for D minus and 1 for D plus, which will give me the level of significance. In case, say for example, if D was at 3 levels, which is say for example D1, D2, D3. So, obviously, there would be 3 cuboids, 1 for D1, 1 for D2 and 1 for D3, and we can basically find out those combinations accordingly. But for this example, let us concentrate on these 2 cuboids at level of D minus and D plus. So, these are the one. So, what you have is basically the combined factors coming out from A, B, C combined, and they are combined in such a way that you can find out at the corner points the combination of AB, BC, AC and the combination of ABC taken 3 at a time. 3 means you are basically combining them together. So, when you have basically the effect of BC, if you remember the rates on the rightmost column, the filtration rate. So, those values were given. So, this is 80, a combination of AC has a 60 rate filtration rate and a combination of AB has a filtration rate of 65. Similarly, when you go to the higher level of D plus, the combinations come out significantly in the same way. You have basically CDS 75, you have the combination of BDS 45, you have the combination of ADS as 100. So, these combinations would give you the values at which you are trying to find out the level of significance. So, again the run values are giving in the first most column. I will highlight it. The effect of ABC, D is not there in the picture because we are trying to eliminate D. It can be elimination of A or elimination of B or elimination of C depending on how you think the importance is. So, you have the combination of basic designs, A being on the second column, B being on the third column, C being on the fourth column, and the designs are given in such a way that you have basically D, which now combines the combination of ABCD to the highest possible extent. The treatment values are given, which basically signifies very significantly in this way. So, if the combinations are A is plus, B is plus and C is plus, that means you have already taken A, B, C combined, and if the combination of D which you are trying to find out as a combined combination of A, B, C, if that is also plus, that means now we have the effects of AS plus, BS plus, CS plus and DS plus also, hence the label would be denoted as A, B, C, D. That means you are trying to combine all of the factor effects together. If you see the second last row, so you have basically A minus, that means the effect of A is not there, but definitely there is an effect of B, there is an effect of C, but the effect of D also which is for A, B, C is not there. So, hence the effect would now be labeled by the combination of B and C. If you go to the run number 6, this is plus for A and plus for C. So, it will be a combination of AC and so on and so forth, and the filtration rates as you note down are given in the last most column, which is just a replica what we have done from the initial table. So, using the definition relationship, we note that each main effect is aliased with 3 factors interactions and they are as follows. A is given by A square B C D, because now you have basically B C and D is being combined by the combination of A B C taken together. Then you have basically the combination of B given as A B square C D, combination of C given as A B C square and D. Square means the effects which is being coming into the picture, that is C square means there are 2 level of effects which is coming from factor C. Similarly, if it is A square, it will mean the effect of factor A is coming in 2 fronts. If it is A cube, it would mean the effect of A is coming on 3 fronts. And similarly for D, it will be given by A B C D square. Furthermore, every factor in interaction is aliased with another 2 factors such that you can break it up accordingly and basically reduce the level of calculation, but the effects of the output would be the same. That means, you are trying to get the maximum amount of output from the information, giving the number of calculations has been reduced. At this point we would normally randomize the 8 runs and perform the experiment, because we have already run the full 2 to the power 4 design. We will simply select the 8 observations in order to make our life much simpler. So, what we are trying to do is that convert 2 to the power 4 combinations into 2 to the power 4 minus 1 suffix Roman 4, such that the effects are coming out to the maximum possible extent. These observations are shown in the last column in table 8.3. So, based on that, when we find out the effects, the effects are given, and we basically given them in a table. So, these effects are as follows in 8.4. So, you have estimated values of A. So, this A does not mean A only, it is a combination of A, B, C into whatever levels we have taken. So, the estimate of A is 19, estimate of B is 1.5. Similarly, if you go down, the estimate of D is 19. And the allied structure which is given basically means A has a combination of effect of A separately and B, C, D taken separately. If I consider the effect of B, it is basically effect of B separately and A, C, D separately. So, what you are trying to do is that trying to factor them in such a way that if it is only for A, it signifies 2 levels of effects. One is coming only from B and one is coming from the effect of A, C, D, where individually all of them may have an effect on B. What we are trying to do is trying to reduce the amount of calculation and find out the combined effect of A on B, of C on B and of D on B, such that the combination would give us the best result. Similarly, when we go to the combination of AD, it is basically a combination of AD taken together and BC separately, such that B gives effect on AD, C gives an effect on AD, such that the combination of BC would give us the best effect. From inspection of the transformation as given in table 8.4, it is not unreasonable to assume that the effects are done in such a way that they give us the best possible combination of result in order to find out the factorial effect of 2 to the power 4, but now the overall number of calculations have been reduced to the maximum possible extent. For a 5 factor in a manufacturing process, so I am just giving you the gist and the calculations would come out very automatically. So, first you have to do is basically find out the table of the plus and minus. Plus and minus basically gives the level of significance, and then you basically break them into the Elias effect and find out the combinations accordingly. 5 factors in a manufacturing process for an integrated circuits were investigated, and we want to find out the fractional factorial experiment based on the factor of 2 to the power 5 minus 1, and the suffix would basically depend on the level of significance, which would denoted by either 3 or 4 or 5 on the Roman script, such that it will give you the level of significance for the experiment. The 5 factors are for this manufacturing process are aperture, setting which is A, B which is exposure time, and remember that when I am reading A effect or B effect or C effect, I will also mention to what level of significance each of them has on the overall factor. So, again I will repeat it, the 5 factors are A which is aperture setting, which will be small and large. So, that means A has an effect on 2 levels, B which is exposure time would basically be 20% below nominal and 20% above nominal, again 2 factors, 2 effects for those factors. C would basically be the develop time, which is 30 seconds and 45 seconds, again 2 levels of factors for C. D is the mask dimension, which is small and large, again 2 effects from coming out from D. E is the H time, which is 14.5 and 15.5 minutes, which is again 2 levels for D. And finally, for E and which is for 2 effects for E. So, hence basically we have 5 factors each at levels 2. So, it is basically 2 to the power 5. Notice that the design was constructed by writing down the basic design of 16 runs, which is basically 2 to the power 4, because initially you can consider only A, B, C, D. Now, as I add another factor, it becomes 2 to the power 5. Now, selecting A, B, C, D, E as a generator, what we are doing is that then we are setting the combination in this way. Either you can basically combine them. So, let me go back one step back. Initially, you had A, B, C, D as factors. Now, a 5th factor E is coming. Now, when you add a 5th factor, it can happen in these ways, 2 ways. Either start the experiment from base levels, where you attach thus the fifth factor as a new one and do the calculations afresh. Other way can be you add E and combine E in such a way that E will give me the overall effect of the combination of A, B, C, D taken together at a time. So, this is what I mean. So, the identity so called effect would be coming out from A, B, C, D, E, but the combination of A would be done or combination of B would be done or the combination C would be done and D so on and so forth will be done in such a way that the factors effects are separated into two fronts. Number one front is the combination of A, B, C, D, and on another front basically you will have the effect of E only, but combined in such a way that the overall effect would come out to the maximum possible extent. Thus, the design is of resolution 5. So, we will basically have an experiment of factorial design of 2 to the power 5 minus 1 with the Roman suffix of 5, such that you are able to basically bring out the maximum possible effects to the highest level, such that we get the best answer. So, with this I will close the 24th lecture and continue discussing more about the fractional factorial design with this example and other examples, so that it will be much easier for us to appreciate how we have been able to change the overall individual factors where the calculation becomes more cumbersome in a much nicer way, such that the fractional factorial models can be brought into the picture and give us the same level of results. With this I will end the lecture and have a nice day. Thank you very much.